So last class we went through some review for the end of our Unit 1, and before you take the test today, I'm going to have you guys do a little bit more review. So you should have this sheet in front of you, and I'd like you to just follow along. Problem number 1 says to use the order of operations to evaluate each expression. Order of operations, we know, is PEMDAS, and you use PEMDAS to evaluate expressions. Expressions have numbers in them, no equal sign, no variables. So when that is the case, we want to evaluate, find the answer using our order of operations, PEMDAS. Now, the first part of PEMDAS is parentheses, P for parentheses. There are no parentheses. One of the things that you can think about, though, with parentheses is sometimes when you see a fraction bar, sometimes you can think of that as parentheses as well. And so actually, let's go ahead and do that first. You could do this step with multiplication division as well, but when we see a fraction, oftentimes I kind of like to do that first because that's kind of like a grouping symbol like parentheses. So when you see that fraction, we can do that. So 48 plus 50 over 5, 50 divided by 5 is 10, and minus 6 squared, right? So we did that. Now we're moving on to the exponents. Do we have exponents? Yes, we do. 6 to the power of 2. 6 squared, remember, means 6 times itself, which is 36. So we have 48 plus 10 minus 36. Move on to any multiplication, division. Those are grouped together. There is no multiplication or division in this problem, at least that is left, because we already took care of that 50 divided by 5. So we'll move on to addition, subtraction. We do that from left to right. So 48 plus 10 is 58. 58 minus 36 is 22. So our final answer there is 22. In B, here you can see, again, when I'm referring to a fraction bar with PEMDAS, we can see that there is a fraction bar here. So this entire top has to be done before we do anything with the bottom. And so on the top, though, we do see that we have parentheses. We have a 7 times 2 minus 5. So 7 times 2 minus 5, 7 times 2 is 14. 14 minus 5 is 9. We had to do the multiplication before we subtract. So we end up with 5 minus 3, and inside the parentheses, that reduces to 9 over negative 2. Okay, now that number in front of the parentheses means that 3 is being multiplied by what's inside the parentheses. So we have to do the 3 times the 9 before we can subtract. We can't do 5 minus 3 to get 2. We have to do the multiplication first. All right, so that gives us 5 minus 27. 3 times 9 is 27 over negative 2 divided by negative 2. 5 minus 27 is negative 22 divided by negative 2. A negative divided by a negative is always a positive. So negative 22 divided by negative 2 is 11. So that's PEMDAS. Now, in number 2, we're on to solving equations. When we are solving equations, we use the reverse order of operations. We use SADMEP. Remember, that's PEMDAS spelled backwards. And another thing that we talked about is when we are going through and solving equations, we have an equal sign. We draw a line down on the equal sign to remind us that there are 2 sides of the equation. And we're working our way back to the x. We're undoing everything with the x, working our way for the more complicated problems from the outside in. So we work with the numbers that are farther away from the x, back to the x, but still trying to get x by itself on the same side of the equation. Normally that involves doing some subtracting or adding first. So we look at same side of the equation as the x. Is there any adding or subtracting? In this case there is. There's a plus 2. And we have to undo it by doing the opposite. So the opposite of adding is to subtract 2. That cancels out. Bring down what's left. So we have x left. Negative 11 minus 2. Be careful with that. Getting more negative, so that's negative 13, and then that is all there is to that problem. X equals negative 13, or 13 equals, negative 13 equals x, I should say. All right, next problem. Another one-step problem here. Again, we look at any subtracting or adding. In this problem, there is no subtracting or adding that is done. So then we move on to, is there any dividing or multiplying that we have to undo? Well, this fraction bar really means divide. So x divided by -5 is what we see, and we have to do the opposite. We have to multiply to unlock it. To get rid of that -5 on the bottom of the fraction, we have to multiply it by -5 kind of in the numerator of the fraction, which simply cancels that out, brings down what's left, x, and we had to do the same thing to both sides of the equation, so we multiply the other side by -5 and we get positive 20. So x equals positive 20. In C, we talked about problems like this last class, and this sometimes trips people up, but that negative x really means a -1x. So 12 is equal to -1x. And when we have a number next to the variable, remember what that really means is they're being multiplied. This is -1 times x. So to undo multiplication, we are going to divide, and you're dividing by whatever that number is, in this case -1, and so you bring down what's left, which is just x, and on the other side, 12 divided by -1 is -12. So basically when you have that, you flip the sign with the x and you flip the sign with the other number, so positive x is equal to -12, or -12 is equal to x. D, we have some options with D. We talked about this like the last problem, is a number next to a variable. So this is really 3/4 times x. So one thing we can do is to divide both sides by 3/4. Now if you type that into your calculator, dividing by 3/4, you could change it to a decimal. So 3/4 is the same as 0.75, so you could divide both sides by 0.75 or 75/100ths. If you're going to type it in like this, you want to do divide, parentheses, 3 divided by 4, close parentheses. So you want to be a little bit careful with that. And when you divide 15 by 3/4, you can type that into your calculator, and you get an answer of 20. So cancels it out here, bring down what's left. X is equal to 20. Another way of doing this problem, which I think sometimes works even a little bit better, is to think of it as 2 steps. First, we could undo the dividing of 4 by multiplying by 4, just kind of like we did back in B here. Bring down what's left here. We've got 3x. 4 times 15 is 60. And then we can undo the 3 times x by dividing. Opposite of multiplying is dividing. And 60 divided by 3 is 20. So either way, you get x is equal to 20. Those are a couple options here. All right, E. You've got a SADMEP problem again, like all of these are when we are solving. But this one is 2 steps. So switch colors here just to give us something a little bit more interesting. Draw a line down at the equal sign. Remember, the first step is to undo any subtracting or adding. So in this one, we are going to add 19 to both sides. Remember, you are undoing what is on the same side of the equation as x, working your way back to the x. So that cancels out the -19. Bring down what's left, which is 2x. -5 plus 19 is going to be positive 14. All right, our second step is to undo any dividing or multiplying. If it's there, we have a 2 times x, so we see multiplying. To undo it, we're going to divide. Cancel out, x is equal to 7. All right, next problem. Once again, think of your SADMEP steps. We're going to undo any subtracting or adding first. Now, when we say subtracting or adding, we're usually referring to the number here, the number, because we're working our way back to the x. So we can't do the 2 first, because the 2 is with the x. We have to work our way from the outside in. So we will start by subtracting 34 from both sides. Bring down what is left. X over 2 is equal to -6. 28 minus 34 is -6. And then we're going to undo any dividing or multiplying. So we're going to undo the dividing of 2 by multiplying both sides by 2. And now we have x is equal to 2 times -6 is -12. The last couple problems involve just a little bit more work. This one, before we can do the SADMAP steps, we have to do a little combining of like terms. So let's put the x's together. We've got 5x plus 2x minus 9x. Okay, we've got to put all three of these x terms together. 5 plus 2 minus 9 is negative 2. 5 plus 2 is 7. 7 minus 9 is negative 2. So we have a negative 2x when it comes to all those. Those all combine to a negative 2x. Then we also have some like terms with a minus 10 and a plus 7. Well, what is negative 10 plus 7? If you're careful, you'll notice that that is negative 3. So we really have a minus 3 and then equals 9. All right, so that's a little tricky because it adds some negatives in there, but combining like terms, we get negative 2x, and combining our other like terms, we get a minus 3. From here on out, we can use our SADMAP steps, just like we did back in problem E. So now we'll add 3 to both sides of the equation, bring down what's left, negative 2x and 12, and then we will divide both sides by negative 2, and we get x is equal to negative 6. 12 divided by negative 2 is negative 6. H, last one on the first page here. This one, we'll have some combining of like terms on this one too, but notice that it's a linear equation and we've got some distributive property that we really should take care of first. Remember, when that number is in front of parentheses in a linear equation, not when it's quadratic, not when there's an x squared or x cubed. We have to be careful then. In a linear equation, we want to multiply and distribute that 4 to both terms. So we've got 8x minus 20, 4 times 2x is 8x, 4 times negative 5 is minus 20, plus x is equal to 7. Now we have to think about our like terms. So we've got 8x plus x, so those two together would be 7x minus 20. So 7x is the 8x. Oh, sorry, that's an 8x plus x, isn't it? I was thinking about a minus x. So that's actually 9x. 9x between those two. Minus 20 is equal to 7. All right, now we will go ahead and solve, undoing the subtracting or adding first. We're going to undo the subtracting of 20 by adding 20. So now we've got 9x is equal to 27, and we will divide both sides by 9 and run out of space here, but x is equal to 3.